Hello dear students, so today we are discussing the chapter surface areas and volumes of our class 10. So in this chapter we are discussing the combination of solids. We already discussed about the surface areas and volumes of solids in our earlier classes, that is in 9th and 8th classes. So today we are discussing its combination. So in this section or in this chapter we are mainly discussing surface area of combination of solids and volume of combination of solids. Then we can familiar with our solids. Which are the different types of solid? We are already familiar in our earlier classes. First one is cube. Okay, are you familiar with the cube? How many faces a cube has? Okay, this is cube and it has 6 faces. And what is the speciality of each edge of that cube? That cube has always equal edges. That is, its edges, if I consider one edge as A, then all edges of cube will be A. Okay, then consider the base or consider the shape of one face of cube. What is the speciality of that face? Yes, its edges are equal, so the face of a cube is always a square. So, if I consider the area of one face, what will be the area of one face? First face, if I consider this as a face, it has side A. So, what will be its area? A square. And how many faces does it pose? 6 faces. So, what will be the total surface area of cube? Total surface area of cube is 6 into A square, that is 6A square. So, write it down. The formula for finding total surface area of cube is equal to 6 into A square, that is 6 times A square. We have one face, if the area of one face is equal to A square and we have 6 such faces. So, the total surface area of cube is equal to 6A square. And what will be its volume? A cube. How will you got that? We have a general formula to find out the volume. What is that? Base area into height. Base area into height is equal to volume. Then we are already familiar about the base area. What is its base? A square. Square. So, its area is A square and height is always equal to A because it is a cube and its all sides are equal. So, A square into A is equal to A cube. So, we got the formula. So, for finding the total surface area and cube volume of a cube. Okay, then we are moving to next solid, that is cuboid. What is the speciality of cuboid? If you consider with a cube that does not possess sides of not equal length. Okay, so here we consider a cuboid with a length. Okay, here we consider a length. So if I consider this as the length and this will be the breadth and this will be the height. So, we have length, breadth and height of cuboid as L, B and H. Okay, then what will be its total surface area? We have 2 faces of area LB because this face has area LB. Here we have length L and breadth B. So, we have 2 such faces. So, 2 such faces have area LB. Similarly, 2 such faces have area BH. And similarly, 2 faces have area LH. So, what will be its total surface area? 2LB plus 2LH plus 2BH, that is 2 into LB plus LH plus BH. If a cuboid has length L, breadth B and height H, its total surface area is equal to 2 into LB plus LH plus BH. Clear? Then we are moving to our volume. What is the general formula? Base area into height. And if I consider base as this side, what will be its area? Length into breadth. Okay, then what about its height? Yes. So, what is the volume of a cuboid? Volume of cuboid is equal to length into breadth into height. Clear? Then we are moving to next solid, that is cylinder. Okay, while we considering this cylinder, how many faces does it have? Okay, 3 faces. Here one face and here also one face. What is the speciality of those 2 faces? Those 2 faces are of equal area and the shape of that faces is Yes, circle. That is base. It has a circular base. Okay. Then what about this surface? That surface is a curved surface. So a cylinder possesses three surfaces or three faces. Two of them are circular in shape and one is a curved shape surface. Okay. So the total surface area will be the sum of these three faces. Then we are considering this cylinder possesses radius r and height h. Okay, so what will be the base areas? Here we have two bases. And what is the area of first base? This base possesses area pi r square. And here also we have a pi r square. So what is the sum of those base areas? Pi r square plus pi r square, that is 2 pi r square. And we have a curved face, and that curved face have area 2 pi r h. Okay. So what is the total surface area of a cylinder? The sum of 2 pi r h, that is curved surface area of cylinder, plus base area of cylinder. That is curved surface area 2 pi r h, base area 2 pi r square. I think you got it, because we have two bases and one base have pi r square. We have two such bases. So base area is equal to 2 pi r square and total surface area is the sum of these two areas. So total surface area is equal to 2 pi r into r plus h. Then what about its volume? Volume is the product of base area and height. And base area, what is the base area of circular face? Sorry, cylinder. It has circular base. So its base area is pi r square. Then what about its height? It is taken as h. So what is the volume? Pi r square into h. Okay, clear? Okay, write down all the formulas in your notebook, because it is very, very important while you are doing a word problem. Okay, then we are moving to next solid, that is cone. So here is the cone. If I consider this cone, how many faces does it possess? Only two faces, that is one circular base, circular face and a curved surface. Okay, so the total surface area will be the sum of these two faces. Then what is the total surface area? It is the curved surface area of cone plus base area of cone. Okay. Then curved surface area of cone is equal to pi into r into L. You are already familiar about the letter we used here. What is r? It is radius of the cone and L is the slant height of the cone. Okay. Then we are moving to base area. What is the shape of base? Yes, it is in circular shape. So its base area is equal to area of circle, that is pi r square. So the sum, that is total surface area, is equal to sum of pi r l and pi r square, that is pi r into r plus l. Then what about its volume? Actually, this cone is a 1/3 part of a cylinder. We are familiar about the volume of cylinder. What is the volume of cylinder? Pi r square h. And this cone is 1/3 part of cylinder. So volume of cone is 1/3 into volume of cylinder, that is 1/3 pi r square h. Clear? Then while you are considering a cone, we have a relation connecting radius, slant height and height of a cone. So we are going to discuss that. If we consider this cone, here we have radius. Okay, it is the radius of the cone. And if I consider this as the height of the cone, and here also we have the slant height of the cone. Can you say which type of triangle was this? Yes, it is a right-angled triangle. So if you got a right-angled triangle, it is clear that it satisfies a Pythagoras theorem. And we have the sides of right triangle as L, H and R. Okay, so if you apply Pythagoras theorem here, we can form a relation connecting L, H and R, right? So what is the relation connecting slant height, height and radius of a cylinder? Yes, L square is equal to H square plus r square. So this is the relation connecting slant height, height and radius of a cone. So if you got radius, you can find, if you got radius and slant height, you can find height. So if you know any two values, you can find the third one using our relation. Okay, so that's all about cone. Then we are moving to our next solid, that is sphere. Okay, how many faces sphere pose? Only one face. So it has a curved surface area or a total surface area which is equal to 4 pi r square, and the volume of cube is equal to 4 sphere is equal to 4 by 3 pi r cube. Then while we are discussing the hemisphere, this hemisphere is the half of that of our sphere. Okay, so this curved surface area of hemisphere is equal to 2 pi r square. Curved surface area is equal to is the half that of the sphere, that is equal to 2 pi r square. And how many faces does a sphere possess? 2 faces. Okay, then we already discussed about the curved surface area. What will be its base area? Base area, its base is in the shape of circle, so its base area is equal to pi r square. So what is the total surface area of a hemisphere? It will be the sum of curved surface area and base area, so that is equal to 3 pi r square. Okay, then we are moving to consider our volume. Volume will be the half that of our volume of sphere. Then what will be the volume of hemisphere? Volume of sphere is 4 by 3 pi r cube. Then volume of hemisphere is equal to half of the volume of sphere, that is 2 by 3 pi r cube. So these are the very important formulas we want to know while you are discussing the problems. Okay, then we are moving to our next slide, that is the combination of solids. Okay, here we can see a figure. Actually this figure is the combination of 3 solids. Which are the 3 solids here? Here we have hemisphere, here we have cylinder, and here we have cone. Okay, when you want to find out the total surface area of this solid, this combination, how will you find that total surface area? Is it required to find the total surface area of cone plus total surface area of cylinder plus total surface area of sphere? No, because we don't have all surface in this figure. We only have the curved surface area of sphere, hemisphere, and curved surface area of cylinder and curved surface area of cone while combining these 3 solids. Okay, so if you want to find out the total surface area of the combination of solids, just add the curved surface areas of all these solids. Okay, so the total surface area of this solid is equal to curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of cone. Okay, then what about the volume? Yes, while considering volume, you want to add volume of each solids, that is volume of hemisphere plus volume of cylinder plus volume of cone. So that is the difference between to find the volume and the surface area of combination of solids. Okay. And here is a question. 2 cubes each of volume 64 centimeter cube are joined end to end. Find the total surface area of the resulting cuboid. Okay, so here we have the volume of cuboid. Then here we consider a cuboid. We don't know the edge length of cuboid. Then we have the volume is equal to 64. That is, what is the formula for finding volume of cube? That is equal to a cube. A cube is equal to 64. So if you have a cube, then how will you find a? A is the cube root of a cube. So what is the edge length of that cube, which is equal to cube root of 64 and is equal to 4. So we got the edge length of cube. Then we are combining these 2 cubes, then we obtain a cuboid. So the question is, find the total surface area of this cuboid. Okay, so what is the formula for finding total surface surface area of cuboid? 2 into LB plus LH plus BH. So, if you want to find out the total surface area, we require the length, breadth and height of the cuboid. Okay. So, what is the length of this cuboid? It will be the 2 times that of our cube, because up to here we have edge length 4. Then here we have one more 4. So, what is the length of the cuboid? Length of cuboid is equal to 4 plus 4 equals 8. Then what is the breadth of this cuboid? Breadth is equal to 4. Okay. So, breadth is equal to 4. Then what is the height of the cuboid? Height also is equal to 4. Then we are going to substitute these values in our equation. What is the volume of cuboid? V is equal to 2 into LB plus LH plus BH, and which is equal to 2 into LB is equal to L into B, 8 into 4, 32 plus LH, which is also equal to 32 plus BH, BH is equal to 16, 4 into 4 is equal to 16. So, 2 into 80 is equal to 160. And what is the square unit of the surface area? Unit of surface area is equal to centimeter square if length is in the term of centimeter. So here is it's an important question, that is a repeated question in our board examination. Then we are moving to another question. A medicine capsule is in the shape of a cylinder of diameter 0.5 centimeter with 2 hemispheres stuck each to its ends. The length of the end of the capsule is 2 centimeter. Find the capacity of the capsule. Okay, so here we have a capsule. What is the shape of that capsule? Here we have a cylinder and each end is combined with the 2 hemispheres. So it will be like this. Okay. It will be like this. Then the question is to find the capacity of the capsule. What do you mean by capacity? Capacity means, yes, volume. So, we want to find out the combination of these solids, volume of combination. How will you find volume of combination? Yes, combination, if the question is volume, just add volume of these 2 hemispheres plus volume of this cylinder. Clear? So, we need to find out volume of each solids. Okay, how will you find out the volume of this hemisphere? What is the formula? Yes, 2 by 3 pi r cube. Do you have the value of r? No, we don't have the value of r, but we have the value of diameter. Diameter is equal to 0.5 centimeter. And what will be radius? Radius will be the half of that of diameter, that is 0.5 by 2, which is equal to 0.25 centimeter. So we have the value of radius. Using that radius, you can find out the volume of each hemisphere. Then what will be the volume of the cylinder? What is the volume of cylinder? Pi r square into h. We have the value of radius because the radius of hemisphere and the radius of cylinders are always equal. Then we need to find out the height of the cylinder. Height means this value. Okay, the whole length is equal to 2 centimeter. That's already given in the question. The whole length is equal to 2 centimeter. Then what will be the length of this cylinder? Subtract the heights of those 2 hemispheres. What is the height of those 2 hemispheres? It will be equal to the radius of the hemisphere. So subtracting 0.25 from this side and 0.25 from this side. That is subtracting 0.5 from the whole length, we will get the length of the cylinder or the height of the cylinder. So this length will be equal to 2 minus 0.5, that is equal to 1.5 centimeter. So now we have all the values and we can substitute these values in our equation. Total volume is equal to volume of 2 hemispheres plus volume of cylinder. Okay. Then volume of 2 hemisphere is equal to 2 into 2 by 3 pi r cube plus volume of cylinder is equal to pi into r square h. Now we have all the value. We have the value of radius and we have the value of height. So just substitute these values in our equation. Then we will get the answer. And what will be the unit of volume? Unit of volume will be in the centimeter cube. Okay, so it's all about this problem. Then we are moving to another problem. 12 solid spheres of same size are made by melting a solid metallic cylinder of base diameter 2 centimeter and height 16 centimeter. Find the diameter of each sphere. Okay, so here we have a melting problem. So what will be the relation here? Then if you melt a thing into another shape, the volume will be always equal. Okay, so the volume of this 12 solid sphere is equal to 12 into volume of this sphere is equal to volume of our metallic cylinder, volume of our cylinder. Okay, then we don't know the volume of each sphere. If you got the volume of each sphere, it is very easy to find out the diameter of each sphere. But we have the volume of cylinder. We can find the volume of cylinder. How will you find the volume of cylinder? We already have the values to find out the volume. What is the volume of cylinder? Pi into r square into h, and it is equal to 12 into volume of cylinder, which is equal to pi into r square into h. We already have the diameter. Diameter is equal to 2 centimeter. So what will be the radius? Radius is equal to 1 centimeter. So pi into 1 into height. Height is equal to 16 centimeter. So 16 pi. Okay, then we have 12 into volume of each sphere is equal to 16 pi. Then substitute the find the volume of each sphere. Then if you got volume of each sphere, it is easy to find out the diameter of each sphere. Okay, so that's all about this problem. So we have some different types of problems. That is a problem which related to total surface area. The problem will not be asked directly to find out the total surface area. Maybe it is the question to find out the cloth required to cover, or the price to find out the total surface area of any toy to paint. Okay, so that question will be indirectly, but that type of question will be required to find out the total surface area. And if the questions related to volume, that question is also like this, that is to find out the volume of total capacity of any vessel, or like that, or any room which is in the shape of the combination of solid, like that. Okay, then another type of problem we are dealing is the melting and recasting. Okay, so in such situation we want to note that if you melt and recast it into another shapes, that volume will be always equal. So note these points. So these are some important questions of our chapter surface areas and volumes. Okay, so that's all about our chapter.